All right, so several weeks ago we did a trig unit where we talked about SOHCAHTOA, sine, cosine, and tangent, and that's all of that stuff is coming back to us a little bit. But now, when we did that, we were just talking about triangles, and we also did log sines and cosines. These were just triangles that were floating somewhere on space. So now we're going to talk about them as in reference to rotation angles, which means that we're going to anchor our triangle to a coordinate grid. So you can see right here they've built a triangle. So because of that, one of the angles is always going to be at the origin. And that means your x value represents one leg of your triangle, and your y value represents another. And then you're going to have to find the hypotenuse by using Pythagorean theorem. They show it right up here. They call it R because this is, so if we had a rotation angle, it's like having a radius that's just going around and around and around, right? So this is the radius of a circle, but it also, if it stops right here, becomes the hypotenuse of the triangle that I built. So that's why they call it R. But it's still just x squared plus y, or a squared plus b squared equals c squared. It's just that instead of a, I'm using x, so x squared plus y squared equals, and they're calling it r squared instead of c, or a hypotenuse. And then you just take this, in order to get r by itself, you just take the square root of both sides, and that's where this comes from. So that's how I'm finding my radius. So now, I know that some of you have been tempted this whole time to say sin instead of sine, but it's actually sine. It has an e on the end. This is just an abbreviation. This is cosine. These are all the, I'm just writing out the words. And the reason for that is because we're going to add 3 more. So I want you to know those as well. This is tangent. And the new ones are cotangent. We'll talk a little bit more about all of these in just a few minutes. This one is secant, and this one is cosecant. All right, so sine, remember that was opposite over hypotenuse, but if we do it in reference to this particular triangle that's drawn, I'm going to put a theta right here on the inside. It's hard for you to see that, but this is my angle. This is the reference angle we're talking about right here. So opposite is y and hypotenuse is r. So we're going to do it as y over r. Now there's a reason for that. Now you can still keep thinking of it as opposite over hypotenuse. That's fine. But there's a reason why we're going to do it as y over r. You'll see, not yet, but in a few days. Cosine, that's adjacent over hypotenuse, so that's going to be x over r. And tangent is opposite over adjacent, so y over x. Now these 3 new ones, they are reciprocals of the ones we already learned, which means they're the flipped over versions of the ones we already know. So cotangent is just tangent flipped over, so that's x over y. Secant is cosine flipped over. Now, I'll explain to you, the prefix that prefix means together. So, you can't be together. You have to, a co has to be together with something. So, the first 3 that we learned were sine, cosine, and tangent, and those 2 aren't together. Now, they have a together relationship, but it's not a reciprocal relationship. So, sine has to be co with something else. Tangent and cotangent are co together. So, sine is together with cosecant, and co is already together with secant. So, there's only a co with each thing, right? Each pair has a co. I hope that makes sense, but I'll say it many more times. So, if it didn't make sense this time, hopefully it'll make sense later. So, cosecant has to be together with something. Everything else is already together with something else, so it's together with sine. It's r over y. All right. So here's how we're going to work a problem, and we're going to use our new little ratios to help us find all of our information. So suppose the terminal side of a rotation angle K passes through the point -3, 4. So -3, 4. All right, so here is my rotation angle. That is terrible going through that dot. I did not do well. I should have just straight edge, but either way. All right, so technically, I started in my initial side over here, and I opened up like this. That's what I'm assuming happened to get to -3 over 4, because that's pretty standard operation. But that is an obtuse angle, and remember, we don't like to use obtuse angles. Instead, we like to use acute positive angles. So we're going to draw a reference triangle by drawing from my dot down to the x-axis. It is always to the x-axis, never to the y. right in here. And I'm going to find sine using that. Now, I know because this dot is the dot -3, 4, that this leg is a value of 3, or technically -3 because it went back over here, and 4, which means my hypotenuse. Now, I could plug into this formula, but I know what it is because it's Pythagorean triple, but -3 squared plus 4 squared, that's 9 plus 16, which is square root of 25, which is 5. So my radius is 5, because it's a Pythagorean triple. It's 3, 4, 5, right triangle. So sine is going to be, I'm going to use these values up here instead of, it still is opposite over hypotenuse, but I'm going to use y over r. So that's 4 over 5. Cosine is x over r, so -3 over 5. And tangent is y over x, so 4 over -3. These others are just the originals flipped over. Cotangent is the reciprocal of tangent, so -3 over 4. Secant is the reciprocal of cosine, so -5 over 3. And cosecant is the reciprocal of sine, 5 over 4. Now, as far as the negatives go, the whole fraction is made negative, so it really doesn't matter where you put it. So, for example, on cosine, it is the 3 that's negative, and I put -3 over 5, but that -3 over 5 made the whole fraction -3/5. So when I flip it, it's -5/3. It doesn't really matter where the negative sign goes. All right. So they asked me on the next question, suppose that angle K measures approximately -233.13. Now I assumed, because I just always assume that we're going to go in the positive direction from standard position, but they're saying, what if we didn't go in the positive direction? What if we went this way? And so K is -233.13. They just want to know if these match up to that. So let's check. If that's the negative version, now my calculator is not going to necessarily give me back a negative version. So let me give the coterminal angle to -233.13. So -233.13 plus 360. Oop, I just said 306, that's terrible. -233.13 plus 360, there we go, is 126.87. So that would be the K angle that I have marked in red. But we'll see in just a second. So if I put in sine, or if I solved K, if I solved sine for K, get K by itself. So let's see, I would arc sine this, sine to the -1. So arc sine or inverse sine of 4/5, let me make sure I'm in degrees. I am not. All right. So I'm going to do arc sine of 4 over 5. And I get 53.13. Well, that's this reference angle right here. So if I do 180 minus this, it should give me, that 126.87, which is the red angle, which means that -233.13 does match up with these. Because those are all coterminal angles. They all end in this exact same spot. So this little note down here is talking about our reference triangles. They are always drawn from the terminal side to the x-axis. So I've got two different versions here. This one is drawn from a negative angle, but it goes back to the x-axis. This one is drawn from an obtuse positive angle, goes back to the x-axis. That means always the x is going to be the adjacent leg, the y will be the opposite leg, and the r will be the hypotenuse. So we're going to try and build some of our own and see if we can come up with our angles here. So it says up here in the instructions, we're going to sketch the angle in standard position and then indicate what quadrant the terminal side lies in. So we're just going to make a little sketch. 12 -5, that would be like down here somewhere, right? Over 12 down 5. So, and if this is my terminal side, my triangle is going to go back to the x-axis. They asked me to put what quadrant it terminates in. It's quadrant 4. So this is theta right here. It's always between the terminal side and the x-axis. So it's over 12 down 5. I need to find my hypotenuse. So I can do that with r equals the square root of x squared plus y squared. This is another Pythagorean triple. That's 144 plus 25, which is 169, which gives me 13. So my hypotenuse is 13. So I can find sine as y over r, so negative 5 over 13. Cosine is x over r, so 12 over 13. Tangent is y over x, so negative 5 over 12. These next pieces are just the ones above them flipped over. Cosecant goes with sine, so it's negative 13 fifths. Secant goes with cosine, so it's 13 over 12. And cotangent goes with tangent, so it's negative 12 over 5. All right, we're going to do the same thing down here on 2. We're sketching. So I would encourage you, if you're watching this video, to stop the video and do it on your own and see how you do. And then turn it back on and see if you got it right. Negative 1, 2 would be right here. So I'm terminating in quadrant 2. Draw my triangle. They didn't put, this is angle alpha right here. It's going to be negative 1, up 2. If I look for my radius, the radius is going to be square root 5. I'm going to leave it as the square root of 5. I don't want any decimal answers here. They didn't write out the 6 things, but we want the same ones as before. Sine of alpha is going to be y over r. My y value is 2. My r is square root 5. Now, that's the correct answer. It's just not in correct form. You can't leave a radical in the denominator. So remember, you have to rationalize that. You're going to multiply both the top and the bottom by the square root. And if I multiply the bottom, square root of 5 from square root of 5 would be square root of 25, which is 5. Or multiplying a radical by itself cancels the radical sign and leaves just the number. But if you multiply the bottom by square root of 5, you also have to multiply the top by square root of 5. So I get 2 square root of 5. All right, so cosine of alpha, that's negative 1 over square root 5. I also have to rationalize it, because you cannot leave a radical in the denominator. It's going to give me negative square root 5 over 5. Tangent is y over x, so it's negative 2. Then I just flip these over for the others. So cosecant of alpha, take the original and flip it over because you won't have to rationalize that. It'll be square root 5 over 2. Secant is cosine flipped over, so it's going to be negative square root 5, or it's negative square root 5 over 1. I don't have to keep the 1. And cotangent is tangent flipped over, and negative 2 flipped over is negative 1/2. All right, so those have the little rationalizing piece that you had to be concerned about. So don't forget that you can't leave a radical in the denominator. We're going to have a lot of rationalizing in the next couple of weeks, so get used to that. So negative 3 is going to be over here. Draw my triangle. Make this angle Z, negative 3, negative 3. This is an isosceles triangle, so I'm going to plug in by my radius. It's going to be the square root of 18. Now, that breaks down into 9 and 2, 3 and 3. Group of 3 stays on the outside. So my radius ends up being 3 square root 2. So sine of Z is y over r. So I've got negative 3 over 3 square root 2. Now, can't have a radical in the denominator, but also 3 over 3. Those are both on the outside of the radical, so they can be simplified. That's negative 1 over square root 2. Now I'm going to multiply both the top and the bottom by square root of 2. And you get sine of Z equals negative square root 2 over 2. Now this is isosceles, which means when I go to do cosine, I realize it's also negative 3 over the square over 3 square root of 2. So I'm going to get the exact same thing for cosine. Tangent is going to be negative 3 over negative 3, which is positive 1. And now we just have to flip these things over. So cosecant is sine flipped over. I'm going to flip it over before I rationalize it, so that would be 2 over negative 1, or negative square root 2. it's isosceles, so secant's going to be the same. And cotangent is 1 flipped over, and 1 flipped over is still 1. All right? So far, so good? All right, so take a second and do number 4. I'm not going to do number 4. I'm not going to work it all out on here. This one actually works out nicely because it is another Pythagorean triple, so you don't have any rationalizing to do. There's just going to be some good numbers. What I do want you to see is this little piece down here at the bottom. They ask us, where are only sine and cosecant values positive? So if you look back up here, this is quadrant 4, this is quadrant 2, this one is quadrant 3. Let me write that down. This is quadrant 3. And this one over here is quadrant 1. So once you finish this one, it's in quadrant 1. If I go back and look where only sine and cosine are positive, not everything else, but just sine and cosecant, that happens only right here in quadrant 2. If I go look where only cosine is positive, that's this one, quadrant 4. Only tangent is positive, that's this one up here, quadrant 3. And then the last one where all of the trig ratios are positive, well, I don't see that on any of those I have done, so it must be this one in quadrant 1, and it is. So there's a little mnemonic that helps us remember this. It's going to come in handy a lot later on. It's all, up in quadrant 1 where we start everything, all students take calculus. Now this is telling me where my trig ratios are positive. All of them are positive in quadrant 1. In quadrant 2, students, that S stands for sine and sine's buddy cosecant. T stands for tangent and tangent's buddy cotangent. And calculus stands for cosine and cosine's buddy secant. This again is telling you where these values are positive. They're all positive here. Sine and cosecant in quadrant 2. Tangent, cotangent in quadrant 3, and cosine secant in quadrant 4. So if we're looking at number 7, they're telling me I have an angle G that terminates in quadrant 4. So it starts over here on my initial side at 0, and it terminates in quadrant 4, which means it could go all the way around, or it could just go straight down. I don't know, they didn't tell me that. But I know that I'm going to draw back to the x-axis to make a reference triangle. G is going to go between the terminal side and the x-axis. And they told me tangent is negative 4 over 3. Now, tangent of G, that's y over x, so that's 4 over 3. Now, if you remember, this quadrant has values that are positive and negative, so the 3 should be positive and the 4 should be negative. It's a 3, 4, 5 right triangle. So if I'm looking for sine of G, sine of G will be negative 4 over 5. Cosine of G is going to be 3 over 5. Now remember what we just learned. All students take calculus. The things that are positive in quadrant 4 are cosine and cosine's buddy secant. So that's why sine is negative and cosine is positive. All right, so you're going to do the same thing for 9, for 8 and 9, and see how you do on those. And then the last thing on this is about what we call quadrantal angles. So in this case, I have the terminal side of an angle A that passes through 0, 4. So if I go down here and I draw a coordinate grid, and it passes this. So remember, we're swinging a leg around. So I'm just taking this and I'm swinging this leg around. And it passes through the point 0, 4. Well, 0, 4 is right here, up on top. Well, there is no way for you to draw back to the x-axis here. You can't. It's on the y-axis. There's no way to draw back to the x-axis and make a triangle. So we can't make a reference triangle. However, ratios that we were using, x over r, y over x, those still work with this. In order to find your, you don't actually even have to find your r. Think about this for just a minute. If this is my radius and it's a length of, or it stops at the point 0,4, that means that this radius has a length of 4, because this point up here is the point 0,4. So my radius is 4, which means sine is y over radius, so that's 4 over 4, so sine is 1. Cosine is x over radius, so that would be 0 over 4, which is 0. Tangent is y over x, which in this case is 4 over 0. Can't divide by 0, so that's undefined. Cotangent is just tangent flipped over. Now you can do 0 divided by 4. That's just 0. Secant is cosine flipped over. Well, that's 4 over 0, which is undefined. And then cosecant is sine flipped over. Well, 1 flipped over is still 1. So those are your quadrantal angles. If you plug in sine of 90 or cosine of 90, you'll find that they match up with this exactly. All right, that is all for trigonometric functions.